Let's see the concept of force in this lesson. We have already studied how the body moves, but we don't know yet why, the reason, the cause. Why does it move a body? Why does it stop it? Or why can it be deformed? What is the cause of these changes? Well, here we can get a notion of force, something that we cannot see, but we can observe the effects. So we can classify forces in two groups, by contact or at a distance. For example, here there is a girl using a Pilates ball, and this boy is hitting a ball in a baseball game. At a distance, for example, gravity or magnetism. Deformations can be produced. For example, this is a black hole using gravity to destroy a star, and this girl is deforming this Pilates ball and changing the motion of bodies. For example, when the is hitting the ball, it's changing the movement, and also changing the movement of this ion piece. So we can define force as any interaction between two bodies by contact or at a distance that causes a deformation or a change in their state of resting, that means a rest, or motion, movement. Each unit of measurement is Newton, symbol N. Something important to take into account is that forces have direction, and this can be displayed as something called vector. Vector is like an arrow. There is the length of this arrow that is implying the magnitude, the value of the force. Then the arrowhead is telling us the direction plus the movement towards one point. That is called the sense. The direction is the line where this force is applied. Also important is the point of application of the force, and the vector usually is symbolized with a mini arrow on the top, over the letter. And forces can be added on an object when various forces F1, F2, F3 act on a body. It is possible to determine a total force, resultant force. Its effects are the same as the combined action of all the different individual forces. For example, imagine two boys trying to pull this cord with sand on the top. Well, both are applying forces, and the total force is this one, so you can add all the forces here. But when they are opposite forces in opposite directions, F1 and F2, what will happen here? That the total force depends on these forces, and you need to subtract them. In this case, this arrow is greater, is larger than this other one, so we can subtract this F1 from the F2 to get the total force. The same happens here, trying to push a car, or even for people trying to move this trolley with the sand. Deformations. A cushion is flattened. Flatten is to make flat when you sit on it, and a bungee cord is stretched when you jump. Bungee cord is when people is jumping away from jumping off a bridge. In both cases, the force causes a deformation. A body has been deformed when a force is applied and its length varies along the force's line of action. So, for example, imagine this is a cushion. Okay, you can compress or you can stretch. There is a compression force or a stretching force. In the case of the stretching force, the particles separate, the length increases, and the compression force, what happens is that the particles come closer and the length decreases. So we can classify bodies according to the deformation that they when they are acting a force against them. The behavior of these can be classified into three types. There are rigid bodies. When you apply the force, this can break or fracture. Plastic bodies, they do not regain their initial length. Well, in the case of rigid body, for example, a rock, when you apply a really strong, a really high force, you can break the stone. And this dough made with flour can be changed the shape using forces, but it's not regaining the original shape. And finally, elastic bodies, they deform when a force is applied to them, and they do regain their initial length when the force disappears. For example, this catapult, after the force is applied, you release the rock, and then is regaining the initial shape. So this is also happening with this sponge. When you apply a force, after that it can regain the initial shape. But in the case of pottery, this is something that we can classify the clay and the pottery as a plastic body. When the clay is cooked, you obtain a rigid body, that is this recipe. And so far, this is enough for today about forces.